Okay, we have another antiderivative here, and it's the indefinite integral, or the antiderivative of 1/5 minus 2 over x cubed plus 2x. And this is one where you may not be readily apparent, if you haven't done this long enough, what to do. And so a lot of times what we'll do is we'll rewrite this integral so that we know what to do. And so we have 1 over 5. The part that's giving us the issue here, or I hope, is this 2 over x cubed. So we have minus, and remember we can write x cubed as x to the negative third, and then plus 2x. That was the one that was giving us the problem. And you remember we did this a lot when we took derivatives. When we had this, in order so we didn't have to use the quotient rule and we could use the power rule, we would change the terms in the denominator that had an exponent to terms in the numerator with a negative exponent, and use the power rule rather than the quotient rule, and it was a lot easier. Same difference here. Notice the power of x is not -1, it's -3, so we can use this power rule of anti-differentiation. So anyway, that's about it, and it's a really simple example. So we have the antiderivative, or definite integral, of 1/5 is 1/5 x minus 2, kind of leave those constants there for a minute, times, we go up by a power 1, so -3 plus 1 is -2, over the new power is -2, and then here we get plus 2 times x up by 1 power is 2, over the new power is 2, plus the arbitrary constant c. So we have 1/5 x, and look, -2's cancel, and we get a plus x to the -2, and then here we get the 2's cancels, plus x squared plus c, and then I'm just going to rewrite this because we were given with a positive exponent in the denominator, so I'm just going to rewrite it like that. 1 over x squared plus x squared plus c. And notice you can always check these. That's something I should have mentioned in the other examples, and it's one of the best things I ever was told, and the best things I ever could do for myself when learning, was to check my antiderivatives by taking the derivative and seeing if I got what I started with. And if I did, then I did it right, and that did two things. It made sure I got my indefinite integral right, and it gave me practice on my derivatives. So let's just try that. Why not? I'm gonna do it in. Is red too ugly? I don't know. We'll see. So when I say check, I'm just going to put this check by there. So I'm going to take the derivative. So d dx of 1/5 x plus 1 over x squared plus x squared plus constant c. Should have made a bracket there. So the derivative with respect to x of 1/5 is just 1/5. The derivative of 1 over x squared, remember that's also x to the -2, is going to be -2x, and go back down by a power of 1. -2 minus 1 is -3, and then here we'll have plus 2x, which is the derivative of a constant. Well, it's 0, so let's just clean it up just to show you that we get the same thing we started with. And look, I should say look. I don't know if I really want to do that, but anyway, I was going to draw an arrow all the way up there, but it's a little hard on this little pad. So anyway, in fact, I'm going to take that, erase that. Anyway, it worked, and I really encourage you, as you're working through antiderivatives, and actually, I don't know. I mean, if you're really math happy, like I am, you should. I do it all the time. It's good practice that gets you really good at your derivatives. So anyway, that's the end of that example.